好，那现在2:10，我们欢迎下一场讲者马婷。
Thank you, thank you. 灯有要关吗？还是就现在 ？Okay, thank you. First question here. I know most of the people here just also speaks Chinese. How many of you only speaks English? Please raise your hand. So if not, I'll just speak English then. No problem, no problem. Like I can do it anyway. It's the same for me. So, welcome. So hello, I'm Martin. I know some of you might expect I'm foreigner. No, I just prefer to speak English in my talks because I speak faster that way. There's the link for the presentation down there if anyone wants interested in. I'll put this up for a little while longer if anyone wants it. And also the slides is licensed under MIT and GPL. So if anyone wants to use it, just take it. I'll give every guys another 30 seconds. Cool. So, quick question first. I know there's a lot of talk about Gemini these 2 days at COSCOP from the Google guys, like their Gemini models. How many of you, like actually here, is expecting like me talking about how Google Gemini works? Oh, cool. I'm surprised. That's a good thing. All right. I'm gonna switch slides. Who am I? Like I said, I'm Martin. I'm specialized in HPCs and system engineering. I am a FOSS enthusiast. I do a lot of FOSS. If you find me on GitHub, there's a pile of contributions there. And currently I'm dabbling in AI, just because AI is the next big thing that is also fun, and also HPC, because HPC is my definition of fun. You know, running stuff at like 200 FPS, or like, you know, this thing used to take you 20 minutes to run, and now it runs in 0.6 seconds. That is my definition of fun. I do a lot of open source. These are a list of the larger libraries I maintain. There's Dragon, one of the fastest C++ web framework you can find out there. There's my Llama CPP fork supporting different hardware accelerations from different vendors. Currently on the Rockchip and Tenstorrent cards. Work in progress. There's also Landlock Unveil. It's a system library that emulates OpenBSD's security measures on Linux. And finally, there's Paroli. It's a TTS engine that runs on embedded system and is wicked fast. More relevant to this talk, I wrote the HTTP2 support for Dragon. I wrote something called TLGS. It's a search engine for the Gemini protocol. And something called Gemini, which is a client and server library for the Gemini protocol. And actually, the reason I decided maybe I should give this talk is because I spent probably a week trying to read the HTTP2 specification and understand, oh, you know, like this is like the next web thing, like next evolution after HTTP being there for like decades. And it's like, dude, this thing's complicated. So I spent like a week reading RFCs and trying to like going from the source and like, oh wow, what does the RFC trying to tell me? And since there's a chance for me to talk, and I decided, you know, I probably should guide people to read RFCs, and Gemini turns out to be a really, really good source to be started learning RFCs. Oh, right. Here's my contact information if anyone wants to talk to me after the talk. There's my email. Intentionally doesn't use the @ symbol, so bots cannot find me. There's my website and my website on Gemini. And if you also play VR chat, I'm on there. You can find me randomly at probably midnight Taiwan time. Okay, about Gemini. So Gemini, what is it? We are not talking about the Google Gemini models. It's cool as fuck, I know. I love it, I use it. It's cheap, it's dirt cheap, it's ridiculously fast, but we're not talking about them today. Anyone into crypto? No. No, not this thing again. No, I'm not talking about the Gemini protocol. Instead, well, we are going to talk about the Gemini protocol. It's like HTTP, but it's much simpler. It's easy to implement. You can probably implement it in like 100 lines of C if you try, and probably less than 20 lines of Python. And actually, that's one thing we'll do today and show you how simple it is. And my goal today is to walk through the core protocols and actually read the actual specs with you guys together. And so you guys have a understanding of how RFC is written and the understanding of it. And Gemini is a set of specifications, and we're just going through the core protocol today. And there's absolutely zero commercial interest of Gemini. So if you're here for the money, just using a normal web. Ecosystem, currently the ecosystem of Gemini is just a bunch of passionate people, like thinking, hey, we love this simplicity. It's easy to implement. It doesn't take up bandwidth. You can host it. I remember someone hosting a Gemini server on a ESP32, if I remember correctly. So it's very lightweight, and some people just really love it. And it's also an imagination of the modern web, but if JavaScript and CSS doesn't even exist, and we practically just use Markdown for everything. I know. Some web developers would think like this is horrible, but we're engineers. We are allowed to dream. But before we talk about the actual spec, let's see what Gemini can do. Someone built a Gemini social media. That's the URL if you want to use it. It's a real social media. People post on it. I remember there's like 8 posts per day across the entire platform, which is quite impressive. There's Cosmos, which is a blog aggregator. So people blog on the protocol and just aggregates everyone saying, hey, there's a new post. You can read it. This is my search engine, TLGS. It lets you search. It's basically the Google for Gemini, but I'm not evil. This is one of the 2 major search engines available on Gemini. The other called Kennedy. After the Kennedy Space Center, it's also a pretty decent search engine. But I like my own better. And there's also games. Someone wrote something called Astrobotany, which is a farming game that you can farm flowers. And if you want to use Gemini, there's different Gemini software. This is the software most people use on desktop and sometimes mobile. It's called Lagrange. It's in itself, it called itself a beautiful Gemini client. It's pretty darn good. I love it. And there's Amphora if you want to do CLI. And Buron if you want something very, very lightweight on mobile. Okay, but today we're here to read the spec, so let's do it. The protocol itself. So Gemini itself is composed of 3 specifications. One is the formal specification of the Gemini protocol. Second is the Gemini formal specification for the Gemini gem text document format. And the third one, though, this is not really a formal spec, but it's a high-level overview. And I think before 2023, it's called the Gemini speculative specification. We'll only be talking about the formal specification and a part of the speculative specification today. The gem text specification is not that difficult to read, but I fear that we don't have enough time since I only have 30 minutes today for a talk. And before we start reading, we must learn the RFC languages. So RFCs define a set of keywords that you almost always see in the specification. These are must, should, may, and may not. So must, like we know, like RFCs are specifications, right? They tell you what you can do, what you must do, what you have to do. And any violations of the RFC rules means you violate a protocol. And these four words describe like how you follow the protocol. Must means that you must do this, or your peer must do this. So if you fail to do so, or your peer failed to do so, that's a violation of the protocol. And usually what you end up happening is the connection is broken, and people will complain about you. Hey, you violated the protocol, you should not do this. I will not talk to you ever because your protocol sucks. The second one is should. Should means you really should do it. Like, please, pretty please, let's do it. But no one is actually stopping you from not doing it. So if there's someone saying, hey, if the specification says, hey, you should do it, you should. But you are free to not to. And as a server or client implementer, you should expect the peer to not do it and be able to survive like the words from the peers. And there's also may, which is basically should, but saying you can do it, we really don't care. It's the same in terms of when you actually implement stuff. And finally there's not, which means not. If you something just said must not, it means it should never happen. And if it ever happens, that means you violated the protocol and people will yell at you. And we start reading the actual specification. This is like literally copied from the Gemini spec. So it says Gemini is a client-server protocol featuring request-response transactions broadly similar to Gopher or HTTP. Connections are closed at the end of every single transaction and cannot be reused. When Gemini is served over TCP/IP, servers should listen on port 1965. So what does this tell us? It gives us a quick description of what Gemini is. Like I said, Gemini is a client-server protocol. It's like HTTP and Gopher. Gopher is an ancient protocol before HTTP ever exists, featuring request response. So if you are familiar with HTTP, you know how request response works. And the default port is 1965. But what Gemini transaction means, like we saw it in the quick description, and then the specification actually tells you, hey, this is how Gemini transaction works. So a transaction is first the client just opens a connection to the server accepts it, and the client server finishes the TLS handshake. Client validates the server certificate. Sends request, one line CRLF terminated lines. What is this? We'll see later. It sends response header. Server sends response header and the actual response body to the client. And then finally, server closes connection and a Gemini transaction is completed. Okay, so we probably have a good high-level understanding on what's happening for Gemini. Right. Okay, client sends request, server sends response, but what is this actual format? So, and then if you read like literally one paragraph after, the specification tells you what the Gemini request looks like. It says Gemini requests are a single CRLF terminated line with the following structure, and URL, and then CR and LF. URL is a UTF-8 encoded absolute URL, including a scheme maximum length of 1,000 bytes, and request must not begin with a byte order marker. What does this mean? So if you are anywhere familiar with programming, you probably know what CRLF is. That's the /r/n character that you print it in order to move your cursor down a line or move your cursor back to the beginning. The protocol simply says, oh, you need both to exist. And a request is simply a single URL. But then the request, and the spec starts to describe what the request looks like longer and longer. I won't read this. Basically, it says resource hosted at Gemini are identified as URIs with the scheme Gemini. The scheme here, it just means that in your URL, we used to type HTTP : / your host. That HTTP in URL terms is called a scheme. And with Gemini, it's simply replace your HTTP or HTTPS with Gemini. Well, the URL specification, it's RFC, but we won't get into there right now because URL is probably quite common, and there's a lot of libraries that deals with for us. In particular, the authority component is not allowed and required, but user info subcommand is not allowed. So it turns out URL, no one uses this feature, but you can put your username and password in the URL to log into services. No one really uses this anymore, so Gemini simply says, no, don't use it, we don't allow it. The host subcomponent is required, so that means you have to type your host name in, which makes sense. The port subcomponent is optional with a default value of 1965. We just saw it, Gemini by default listens on 1965 port. The path, query, and fragment components are allowed and have no special meanings beyond the defined by the generic syntax. So the path is, the path in HTTP, and the query is the same stuff that we use in HTTP. Fragment, if you don't know, it's like the hashtag after the HTTP in your normal URL. And then an empty path is equivalent to a path consistent of only slash, and spaces in path should be encoded as %20, not a plus. Okay, this is just basic URL encoding questions, so I won't spend time to dig into that. Client should normalize URIs before sending the request, and servers should normalize receive URIs. Here we see the specification actually says you should do this. So the client should normalize the URI, and the server, when received, it should also normalize the URI. This means that as a server, you should be expecting the client to implement this, but you should really be prepared to not. And as a client, you really should normalize your URI before sending it out. But the server could not, and you cannot yell at the server's author and say, "Hey, you did something wrong." You cannot. You simply have to error out to handle something yourself. So from we just read, we can imagine this is actually a Gemini Gemini request. It's a URL with the HTTP replaced with Gemini and /r/n as the ending. And we can read the Gemini spec of a response. Gemini responses are composed of a header and optional body. Oh, well, this looks surprisingly like HTTP. And it then tells you in detail what Gemini response looks like. Gemini response headers looks like this. It's a status code space a meta field and then CRLF. CRLF being the /r/n we are all familiar with. The status is a 2-digit code that describes like your status, and it's defined in Appendix 1. We'll go through that later very quickly. Space is just the space character, ASCII character we're familiar with. And meta is a UTF-8 string that conveys some information about the response. So here's a status code in Appendix 1. It simply is 1. It's a 2-digit code, and there's 6 categories. There's input, success, redirect, temporary redirect, permanent redirect. Temporary failure, and permanent failure, and something called client certificate. But we'll just look at the ones that we actually care about. There's status code 20, which is equivalent to HTTP 200 success. That means you actually found something and the server is able to reply. And the specification says when the server replies code 20, the request was handled successfully, and there's a response body followed by a response header. The line is a MIME type, media type, which applies to the response body. So it tells you what the server will tell you what it actually replies, just like HTTP. But status code 15.1 is analog to HTTP 4.4, and the specification author simply says, how do you remember this? Well, easy. You can find anything in AGR 15.1. Okay. From our understanding, this is the simplest Gemini client you can do. You simply export your host, and you send that over to the Gemini server and put your URL there and ask, hey, I want this file. And I'll pray to a live demo gods that this actually works. So, sorry. Control plus. Oops. Okay, so this is the command. It's sending to my server, and if you see here, it says verify equals 0. That's because how Gemini handles TLS. Gemini doesn't want you to use CA. So, sorry. So it's everything is self-signed on Gemini, and usually this fails because most tools assume that you are using a normal HTTP and every certificate is signed. You send this, and we actually see the server sends back the header, which is 20, and the MIME type, it's text Gemini. This is a special gem text format we talked about earlier, which we won't go into, but it's close enough to Markdown. We can just parse it as Markdown, and most of the stuff will work. Yep, that's the minimal Gemini server client. And that's the speculative spec, but we're going to talk about the formal specification. Okay, so the formal specification is mostly the same as the speculative specification, but it's written like the RFC, and RFCs are known for being strict and using the BNF for specifying grammar. It's good material for actually learning how to read RFCs. So, but before we actually reading Gemini, we're going to learn what BNF is. BNF is a simple way to describe grammar on RFCs. So it's in the form of some label equals some pattern. It's a little bit like regex, but it's a lot more flexible and also less performance. Here in the bottom, we defined a BNF that has 4 components. A equals the character A, B is character B, and C is character C. And finally, there's ABC, which is a new string that accepts that is a sequence of A, B, and C. So the following BNF accepts a string ABC. BNF can be more complicated. There could be selections or alternatives. So here the rule called rule accepts ABC or ABD. The slash operator allows you to select between 2 possible options. And there's the dash operator, which is a continuous sequence, continuous range of. So here we define digit as so anything between ASCII 0 and 9 inclusive. So that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the star operator allows you to have a number of repeats. So here we have digit is 0, 9, okay? And there's num. It's 1 star digit. Star takes in two parameters. One is in front and one is after of it. The first one is like the minimal amount that has to show up, and the second is like the maximum amount. If it's not present, it's 0 or infinite. So here we define a number to be at least one digit, and potentially it could be an infinite amount of digits. And the square operator makes something optional. So here we define a floating point format. That's simply a number followed by an optional dot and then another number. Hopefully this makes sense. And we can look at Gemini responses. I know this is a lot complicated, but it follows the same thing. Like a Gemini response is either an input or success or redirect or a temporary failure or permanent failure or authorization error. So like we see about before, input is a 1 followed by another digit. It's a 2-digit code separated by a prompt and then CRF. We'll talk about later if we have time. A success, a status code 20, is a 2 followed by a digit, and followed by a space and a MIME type, and a new line and then body, and the other arrows are all follow the same. You might see some weird stuff like varchar, SP, CRLF, and octet. These are defined in other RFCs. So it's really common that when you are reading RFCs, you have to go to another RFC to learn like what's definition of this and how its definition works. But here we can notice one pretty big difference with these formal specification and overview. With the arrow status codes, like in the speculative spec, we see that it says your body is optional. But here straight up say, hey, you shouldn't have any body with these 3 types. There's no body field, and the body field is not optional anymore. It's different. This is because this is a very rigorous specification, and whenever you are implementing a protocol, follow the rigorous one, because that's the one people is going to use. And there's also another difference with status code 20. It's mandatory to have a body, but before it simply says your body is optional. So in the past, it's allowed to have an empty body on the success response, but in the formal specification, you cannot. It gets deleted. Oh, sorry. I'll just talk through this. Gemini request is simple. It's just a URI followed by CRLF. Sorry, I accidentally deleted that line. Sorry about that. So here's a minimal Gemini server. In Python, we simply open a socket. We load a key. A key could be generated by the following commands on OpenSSL. You probably did it 100 times if you ever wrote web services. Like we said, we bind it to localhost, and we run the server. And we simply listen for request. And the request, since the request is just URL, we pass it to the Python URL. And we parse it. If we cannot parse it, we error out. We try to find the file, and we send a response back, either with 20 saying, hey, we have this data, we return a markdown file, or we said 51, we cannot find it, and send it back. So let's pray to the demo gods again. CD documents, Python. This is the Gemini server, and this is Lagrange, the client. So we can type local. Sorry, I didn't notice I didn't pull a terminal, but sorry. Here's a terminal. That's our Python program running. That's the minimal server, localhost. It says hello world, and Gemini is literally that easy, so we can cat this. Oh, I cannot see it. Cat Gemini server. This is the same code. This is the same easy code. Yep, that's the minimal server. It's really easy, and we just finished reading the course back in less than 30 minutes. I don't think we have time for the additional slides. Sorry, but thank you. Any questions? Hello.
Alternatives.
Sorry?
Besides being an alternative to HTTP, what does Gemini improve, or what kind of features does HTTP does not provide that but the Gemini supports?
There is one I think HTTP should really learn, but besides this, there is zero. Gemini is just a simpler version of HTTP that has zero value, to be honest. Gemini supports something called client certificates. So in TLS, you can put certificates on the server, and it secures the server's connection to a client. But the client cannot authenticate to the server in the same way. But Gemini validates this because it's so simple. It has to rely on lower level mechanisms for authentication, and they just ended up using client certificates. So you generate a certificate on your client, and when you create a TLS connection to a server, you take that certificate also to the server. So the server knows, oh, I know this certificate. This certificate belongs to user X, and you log in that way. I think this is pretty smart, because no more passwords. It's just certificate management, which is easier for us engineers. Cool. Anyone else? Yeah.
Is it possible to embed an image in a request?
Request or response?
Request or response.
No, you cannot have a request body, and you can send back images. So it would be your MIME type would be something like image/PNG, and the data would be your PNG blob. Does that answer your question?
Yeah.
Okay, cool. Anyone else? Sure.
So if we want to start our own Gemini blogs, we should probably just sign up for a free hosting service?
Sorry, I cannot hear you.
Okay. If we want to start our own Gemini blogs, probably we should sign up for a hosting service at a place that already does this, like maybe pollux.casa or something. But would our ISP get angry if we just ran it at home and did it over our internet connection at home?
I don't know what the ISP is like on places besides Taiwan, but like Taiwan ISPs are really chill for this.
Okay.
Yeah, it doesn't take up any like bandwidth, because like the protocol is so small and the text is so compact.
So we just write a blog in Markdown or plain text and just put it up there.
Yeah, that's what most people do, but there's also free hosting service, something like, I can share with you later, but there's something like midnight.pub, which gives you free access.
Cool.
Cool. Anyone else? Okay, cool. All right. Thank you, everyone.